All right, let's go. Number 7. The radiation that broke all the models. And we are starting with something that sounds dry, but is genuinely one of the most alarming things Artemis has revealed so far. We're talking about radiation. And before you skip ahead thinking this is just a technical footnote, I need you to stay with me here because what the data showed caught NASA scientists genuinely off guard. When Artemis 1 launched in November 2022, the Orion capsule went up unmanned, no crew, but it was loaded with some of the most sophisticated radiation detection equipment ever sent into deep space. The whole point was to measure exactly what a human body would experience on the journey to the moon and back, so that when Artemis 2 sent a real crew, NASA would know exactly what they were dealing with. The results came back, and the scientists looked at them. And then they looked at their models. And then they looked at the results again. The radiation doses recorded during the journey, specifically during the transit between Earth and the Moon, were significantly higher than what the models had predicted. Not slightly off, not within acceptable margins. We're talking about levels that, had a human being been sitting in that seat, would have amounted to roughly the equivalent of 30 chest X-rays every single day. Now, here's where it gets truly disturbing. Solar radiation and galactic cosmic rays, these are known. Scientists have been modeling them for decades. The instruments were supposed to confirm the predictions. Instead, they found energy spikes, sharp, sudden surges in radiation that did not correspond to any solar flares. No coronal mass ejections were recorded. No known space weather event could account for them. So, where were they coming from? The leading hypothesis from researchers who analyzed the Artemis 1 data is that the moon itself, particularly the regions near the lunar south pole, may be interacting with cosmic radiation in ways we do not yet understand. The top layer of lunar soil, called regolith, may be trapping charged particles and releasing them unpredictably, like a sponge that randomly squeezes itself. This matters enormously because Artemis 3 is planning to land human beings right next to the lunar south pole, in the exact region where these anomalous spikes were detected. And as of right now, we do not have a complete explanation for what is causing them. Engineers are redesigning suit shielding. Scientists are building new models. But the gap between what we expected and what we found is real. And it is wide, and it is sitting at number 7 because, honestly, everything above this on the list is even stranger. Number 6. The South Pole craters and what's frozen inside them. Number 6, and this one requires you to engage your imagination a little, because the scale of what we're talking about is almost incomprehensible. At the lunar south pole, there are craters, deep craters with walls so high and angles so steep that the floors of these craters have not received a single photon of sunlight in billions of years. Not millions, billions. While life on Earth was evolving from single-celled organisms into every creature that has ever walked, swum, or flown on this planet, these patches of the moon were sitting in complete, perfect, undisturbed darkness. We always knew there was water ice down there. Earlier missions confirmed it. But when Artemis-era instruments began mapping these permanently shadowed regions in detail, including the shadow cam aboard the Korean Danuri orbiter, which was flying in direct partnership with the Artemis program, what they found inside those craters went far beyond water. The ice deposits are not clean. They are laced with complex carbon compounds, sulfur dioxide, carbon monoxide, and traces of what appear to be organic molecules, organic chemistry of the kind that, on Earth, we associate with the building blocks of life. Now, I want to be very clear here because this is the kind of thing that gets distorted very quickly. Organic does not mean alive. Organic molecules form through entirely non-biological chemistry all the time in space. Comets carry them, asteroids carry them, interstellar clouds are full of them. But here is the part that has scientists talking in careful, measured, slightly nervous sentences. Some of these compounds do not match known meteorite compositions. They do not appear to be native lunar material. Their origin, based on the isotopic signatures detected, is genuinely uncertain. Where did they come from? The majority view is that these craters have been collecting debris from across the solar system for billions of years, a kind of cosmic graveyard, preserving whatever fell in and was never disturbed. That's the mainstream explanation, and it's probably right. But a minority of credentialed researchers have been very quietly, very professionally, arguing that before we drill into those craters, before we crack open those billions of years old ice deposits, we should do significantly more analysis. Because if there is any possibility, even a small one, that what we are looking at is preserved biological material from somewhere in this solar system's deep history, then the way we open those vaults could be the most important or the most reckless decision in human history. The drills are already being built, the mission timeline is set, and the craters are waiting. Number 5. The moon is moving, and not the way you think. And this one fundamentally changed how planetary scientists think about the moon. For decades after Apollo, we knew the moon experienced moonquakes. The seismometers placed by Apollo astronauts confirmed it. But Apollo was limited. 4 sensors covering a relatively small region operating for only a few years. The picture they gave us was incomplete. Artemis changed everything. The Farsight seismic suite and additional instrumentation deployed through the commercial Lunar Payload Services program running alongside Artemis began giving us the most detailed seismic picture of the moon we have ever had. And what that picture showed is this: the moon is shrinking. Not metaphorically, physically. As its interior slowly cools over billions of years, the crust is compressing inward, creating what geologists call thrust faults, places where the crust is literally buckling under its own pressure. This was suspected before. What the new data confirmed is the scale, and more importantly, the location. The most active seismic zones, the places where moonquakes are occurring with the greatest frequency and the shallowest depth, are clustered near the lunar south pole. The exact region where Artemis 3 is planning to land. The exact region where NASA hopes to eventually build a permanent human outpost. Estimates from researchers analyzing the new seismic data suggest that during a single 14 Earth day lunar period, there could be dozens of seismic events in the planned landing zones, some strong enough to topple equipment, some strong enough to compromise the structural integrity of a sealed habitat, some strong enough to throw an astronaut off balance on terrain that already has essentially no gravity to hold them down. But here's what elevates this from dangerous to genuinely eerie. Some of the seismic signals being detected have a characteristic that researchers have struggled to explain. Normal moonquakes decay slowly, the moon rings like a bell, and the seismic energy bounces around inside it for a long time before fading. That is normal, that is known. But certain signals from the south polar region stop abruptly. Not fade, not decay gradually, they cut off, as if something in the ground is absorbing the energy and ending the signal. Researchers have proposed that ice-saturated regolith in the shadowed craters might have unusual seismic absorption properties. That could be the explanation, but it has not been fully confirmed. And until it is, there are scientists who describe these signals using a word that does not often appear in peer-reviewed seismology papers. That word is unexplained. Number 4. Underground magnetic fields that should not exist, and they're moving. And this is one of the most scientifically strange discoveries in the entire Artemis catalog. The moon has no global magnetic field. Unlike Earth, which has a massive magnetic bubble generated by its molten iron core, the moon's core is too small and too cold to produce one. This has been known for decades. It is settled science. Except in certain places on the moon, it does. These are called lunar magnetic anomalies, localized patches of the crust that generate their own small but measurable magnetic fields. They were first detected during Apollo, but Artemis-era orbital mapping has given us the most detailed magnetic map of the moon ever produced. And what that map shows has genuinely puzzled researchers. The anomalies are concentrated in specific regions. Many of them are associated with strange surface features called lunar swirls, bright, almost painted-looking patterns on the surface that do not follow any topographic feature. No crater, no ridge, no geological boundary. Just swirling, lighter-colored patterns on the surface correlated with these localized magnetic fields. Scientists have multiple theories about how these form. Ancient comet impacts that magnetized the crust, remnants of a period billions of years ago when the moon had a stronger global field, interactions between the solar wind and certain mineral compositions, But the new Artemis magnetic mapping data added something to this picture that none of the existing theories fully anticipated. Some of the strongest anomalies are not at the surface. They are underground, beneath the crust. And they're not static. They are shifting. Slowly, not fast enough to see in real time, but measurably when you compare observations separated by years. Underground magnetic sources that are changing position over time. In a geologically dead rock, that should not happen. Magnetic anomalies in cold, solid, inactive crust do not move. Movement requires an active process, heat transfer, fluid dynamics, something. No one is suggesting anything dramatic. The scientific community is not throwing up its hands. But what they are doing is acknowledging that whatever is happening beneath the lunar surface in certain regions involves processes that are either not yet modeled or not yet understood. And the areas with the strongest underground anomalies, they overlap significantly with the planned Artemis landing and habitation zones. Number 3, the things that cameras caught and can't explain. And I want to be very careful here because this is a section that is most vulnerable to misrepresentation. So let me be clear before I say anything else. I am not talking about alien bases. I am not talking about structures on the moon. I am talking about specific, formally documented, officially acknowledged anomalies in visual data from Artemis-era instruments. Anomalies that were written up in technical reports. Anomalies that were described by the scientists who reviewed them using language like unexpected, unresolved, and warrants further investigation. Here is the first one: transient flashes. Brief flashes of light on the lunar surface have been observed by astronomers for centuries. They're called lunar transient phenomena. Most are explained: meteorite impacts, gas venting from the regolith, electrostatic discharges when the solar wind hits the lunar surface. Artemis-era cameras, far more sensitive than anything previously in lunar orbit, have documented these in greater detail than ever before. Most of what they captured has clean explanations, but a small subset does not. Specifically, a statistically notable number of these flashes occur in the same locations repeatedly. Not where new craters are being formed, not where fresh impacts would be expected. Fixed points on the surface, producing repeated transient flashes over multiple observation periods. What causes repeated location-specific flashing on the lunar surface with no visible geological feature to explain it? There is no definitive answer. The phenomenon is documented, the explanation is not. The second anomaly is more specific and more contested. During a lunar reconnaissance orbiter pass over the Shackleton crater rim, one of the primary candidate landing sites for Artemis 3, image analysts comparing two passes noticed a shadow discrepancy. A shadow appeared to have shifted between the two images in a way that could not be fully accounted for by the movement of the sun. NASA's official position is that this is most likely an imaging artifact, a product of sensor behavior, image stitching, or timing metadata. That is almost certainly the correct explanation, but the analysts who flagged it have not been satisfied with that answer. After correcting for every known source of instrumental error, they maintain that an anomaly remains. They have not claimed it is anything extraordinary. They have simply said, this is unresolved. On the moon's surface, near humanity's planned next landing site, something the cameras caught and science has not yet fully explained. Number 2, and this one is terrifying in a completely different way from everything else on this list, because it is not about the moon. It is about us. NASA has known for years that spaceflight affects the human body. Bone density loss, muscle atrophy, fluid redistribution. These are manageable. These are the expected costs of operating in microgravity. But the Artemis program has generated a new wave of biomedical research, the most detailed ever undertaken, focused specifically on what deep space does to the human brain. And what that research has confirmed is something that even experienced aerospace physicians describe as deeply concerning. In microgravity, the body's fluids shift upward. Without gravity pulling blood and cerebral spinal fluid toward the lower body, they migrate toward the head and chest. This happens to every astronaut. On the ISS, it results in puffy faces and stuffy sinuses, uncomfortable but manageable. But in deep space, on longer duration missions, something more significant happens. The fluid pressure around the brain increases. The brain itself is compressed and repositioned within the skull. The optic nerves are affected, causing vision changes that in some astronauts persist after returning to Earth. White matter, the connective tissue between different regions of the brain, shows measurable changes on post-mission MRI scans, and these changes do not fully reverse. Astronauts who have completed long-duration missions return to Earth with brains that are structurally different from the ones they left with. Some of the changes are subtle, some are less subtle, and the cognitive effects, problems with memory, attention, decision-making, and emotional regulation, have been documented in post-mission performance testing. Now consider what this means for Artemis. The journey to the moon and back takes roughly 10 days at minimum for a crewed surface mission. That is not the years-long Mars mission that produces the most severe effects, but it is deep space. It is outside the Earth's protective magnetic field, in a radiation environment that, as we already discussed, is more intense than predicted. And the astronauts who arrive on the lunar surface will do so with brains that have already been altering for days under those conditions. And then they will have to make clear, fast, correct decisions in an environment with unstable seismic ground, invisible radiation, extreme temperature variation, and finite life support. The human brain is the most important piece of equipment on any Artemis mission, and the mission itself begins degrading it the moment it launches. Number 1. We don't know what we're going to find when we actually drill. Number 1. And in some ways, this is the most frightening of all. Not because of what we know, but because of the precise and specific shape of what we don't. The Artemis program has a definitive goal beyond exploration. One of the central scientific objectives of the lunar South Pole missions is to drill into the permanently shadowed crater floors, extract samples of the ancient ice deposits, and analyze them in detail. This has never been done before. No human hand and no robotic arm has ever disturbed the content of those frozen, lightless vaults. We know from orbital remote sensing that they contain water ice. We know they contain complex organic compounds. We know they contain materials of uncertain origin. We know they sit in terrain that is seismically active in ways that are not fully explained. We know that the magnetic fields in the region behave in ways that are not fully understood. And when we drill into them, we will be the first disturbance those environments have experienced in billions of years. Consider what that means scientifically. The information preserved in those deposits could be extraordinary. Ancient solar wind history locked in ice, cometary material delivered across billions of years, a chemical record of the early solar system that exists nowhere else with this level of preservation. The scientific value is almost beyond calculation. But here's the thing that a growing number of planetary scientists have been raising in formal academic papers and at professional conferences, not as a reason to stop, but as a reason to be extraordinarily careful. We have protocols for planetary protection on Mars. We have protocols that govern how we approach environments where life might exist, might have existed, or might be affected by our presence. These protocols are taken very seriously. The permanently shadowed regions of the moon are not currently classified under those protocols at the same level as Mars. They are treated as essentially inert. But the evidence coming back from Artemis-era instrumentation is quietly building a case that our classification may be wrong, that these environments may be more chemically complex, more active, and more scientifically sensitive than our protocols were designed to handle. And the scariest part is not that we might find something extraordinary down there. The scariest part is that we might find something extraordinary and not recognize it for what it is. That in our excitement, in the pressure of mission timelines and funding cycles, and geopolitical competition in space, we might drill through the most important scientific site in the history of human exploration without the care it deserves. We are going back to the moon. That is extraordinary. That is one of the most remarkable things our species has ever committed to doing. The science the Artemis program has already generated and will continue to generate is genuinely transformative. But the moon is not the quiet, dead, simple rock that the 20th century imagined. It is ancient. It is complex. It is strange. And the 7 things we just went through, the radiation that broke our models, the ancient frozen compounds we cannot fully identify, the ground that shakes in ways we cannot fully explain, the magnetic fields that move beneath the surface, the unexplained lights and shadows, the brains of our own astronauts being quietly altered by the journey, and the sealed deposits we are about to open for the first time in the history of the solar system, all of them are pointing to the same conclusion. We know far less than we thought we knew. And we are about to find out what we've been missing. The moon has been watching us for 4.5 billion years. We are finally watching back.